Hello students, in this video I'm going to be reviewing the Trig Trimester 1 exam from 2016, Part 5, Finding Sides and Sometimes Angles of a Triangle. Number 1, in triangle ABC, and here's the key, capital letter C is 90 degrees. Remember, the capital letters are the angles, the lowercase letters are the sides. So here we're dealing with a right triangle. So I'm going to be drawing a right triangle and putting letter C at the 90 degree angle. Now whether you put angle A on top and angle B on the bottom or vice versa, that doesn't matter. But what does matter is that angle C is 90 degrees. Here you're told little a, the side opposite angle A, is 26.3. So here's angle A, which means the side opposite down at the bottom is going to be 26.3. And angle B is 42 degrees, 35 minutes. We have to go about finding the remaining sides. Little c, so that's the side opposite angle C, and little b, that's the side opposite angle B. Well, since you're given a right triangle, you know that the rule you're going to be using in the problem is SOHCAHTOA. So here's what I'm going to do. I'm going to go about labeling my picture. Here the angle given to you is angle B. That's the 42 degrees, 35 minute angle. So little b is then going to be the opposite side, and little c, that's the side opposite the right angle, that's going to be the hypotenuse. So I have little b is the opposite, little c is the hypotenuse, which means this remaining side then is going to be the adjacent. So let's go about finding little c first. So here's what we have. We have the angle is 42 degrees, 35 minutes. I'm going to go about finding little c. Well, little c is the hypotenuse, and I know that 26.3 is adjacent. I'm not using little b. I'll do that in a few minutes. So here I'm trying to find little c, that's the hypotenuse, and here I know that 26.3 is the adjacent. So what you're going to do is you're going to look at what's given here. We have the hypotenuse, we have the adjacent. That means we're going to be using cosine in this first part, because that's the only one of the three trig functions that has those two parts, the adjacent and the hypotenuse. So I'm going to write out the cosine of an angle equals adjacent over hypotenuse, and now I'm going to plug in the different values. I have the cosine of the angle. Well, the angle is 42 degrees, 35 minutes. So I have cosine of 42, 35. That equals the adjacent, that's the 26.3, over the hypotenuse, which is little c. Now what I'm going to do is I'm going to go about solving for little c. I'm going to put the cosine of 4235 over 1, and I'm going to cross multiply. So I have little c times the cosine of 4235. That equals, when I cross multiply the other way, 1 times 26.3, or 26.3. So here, to solve for little c, I'm going to divide both sides by the cosine of 4235. So here what I'm going to have to do on my calculator is type in this right-hand side. See, these 4235 cosines cancel, so I have little c is equal to this. So I'm going to type in 26.3 over the cosine of 4235. So here it turns out that little c is going to be, to the nearest tenth, because it says sides to the nearest tenth, 35.7. 35.7. So now I have to go about finding little b. Well, the angle is still 42 degrees, 35 minutes. Little b is the opposite. Now, I was given in the problem this 26.3. I went about solving for the hypotenuse and I got 35.7. You should always use what's given to you in the problem. So in this case, I'm going to write down that 26.3 equals adjacent. Now I'm going to try to use SOHCAHTOA. Again, you can't use SOHCAHTOA on any triangle. It has to be a right triangle. So in this case, we were given a 90-degree angle. So here we're going to have opposite, and we're going to have adjacent. Only the tangent deals with opposite and adjacent. So I'm going to write that out. I'm going to write out the tangent of an angle equals opposite over adjacent, and now I'm going to substitute in. I have the tangent of the angle. Well, the angle again was 4235. So the tangent of 4235, that equals the opposite, which was B, over the adjacent, which is 26.3. So now I'm going to go about solving by putting the tangent of 4235 over 1, and I'm going to cross multiply. So I have 1 times B, which is B. That equals 26.3 times the tangent of 42 degrees, 35 minutes. And here, B is already by itself, so all I'm going to do on my calculator is type in this right-hand side. 26.3 times the tangent of 4235. And here it turns out that little b to the nearest tenth, 24 point, and that 6 kicks the 1 up to a 2. Remember, when you do trigonometry questions, you want to make sure your calculator is in degree mode. The way you get degrees and minutes on your calculator is you press second and then the apps button to get to the angle menu. Problem 2, in triangle DEF, angle D is 123 degrees in 10 minutes. So we want to try to draw up our picture, but here we're not given a right triangle. So I can draw any old triangle that I want and just label the sides appropriately. Now it is true that angle D is 123 degrees. That's bigger than 90 degrees, so that makes it an obtuse angle. But to be honest with you, as long as you label your picture appropriately. So here they tell me angle D is 123 degrees, 10 minutes. I'll just draw a triangle and label it angle D, 123 degrees, 10 minutes. Little f, the side opposite angle F. So here's angle F. The side opposite is going to be down at the bottom. So in this case here, little f is going to be 30. And little e, the side opposite angle E, so that's going to be over there, that's going to be 21. We need to go about finding little d to the nearest tenth. So that's the side opposite angle D, so that's going to be right over there. Now, here we're going to go through our list of rules. To use SOHCAHTOA, you need a 90-degree angle, but here we're not given that. To use the law of sines, you need to have one matching set of side angles and one half matching set. So look what I have going on. Here my half matching set are my D's, because here I have angle D and I'm trying to solve for side D. Your half matching set is basically what you're solving for. It has to be the part that you're looking to solve for. Now, as far as my matching set goes, it has to then be either the E's or the F's. Angle E, side E is not a matching set because I don't know angle E. Angle F and side F is not a matching set because I don't know angle F. I know side F, but I don't know angle F. So unfortunately, to use the law of sines, you need to have one matching set, one half matching set, and we don't have that. To use the law of cosines, you basically need 3 sides and 1 angle. Now it looks like we don't have that because it looks like we have 2 sides and an angle. But here we're trying to solve for side D. So we have now the 3 sides and the angle opposite the side that we're solving for. So here I'm going to write the law of cosines rule. D squared equals E squared plus F squared minus 2EF times the cosine of angle D. So here I'm solving for little d, so that's why I wrote the law of cosines where the little d was by itself. So here I'm going to have d squared, or x squared, d squared. That equals little e, so that's going to be 21 squared, plus little f, that's going to be 30 squared, minus 2 times e times f, times 21 times 30, times the cosine of angle D, which they told you in the problem was 123 degrees and 10 minutes. So here what I'm going to do is I'm going to now type in this entire right-hand side on a calculator. So here I have on my calculator 2030.316, and you can see the rest. Now, is that going to be what side D is? That seems a bit large since the other two sides were only 21 and 30. No, this is what D squared is. So the way I'm going to get D is I'm now going to just take the square root of that answer. I'm going to press second and x squared for square root, and the previous answer, which is second and then the negative button. So it looks like here, little d is going to be to the nearest tenth, 45 point, and the 5 kicks the 0 up to 1, so 45.1. It should make sense that little d is the longest side because it's opposite angle D, which is an obtuse angle, which means it's the largest angle in a triangle. Finally, number 3, in triangle GHI, again, I'm looking to see if there's a right angle. This angle G is close to a right angle, but close doesn't count in trigonometry. So here I'm just going to draw a triangle GHI. I'm going to label angle G is 92 degrees, 50 minutes. Angle I, that's a capital, 58 degrees, 20 minutes. And little h, so the side opposite angle H. So here's angle H, the side opposite, that's going to be 16. We have to find little g to the nearest tenth. So we're going to go through our rules. First, we'll look to use SOHCAHTOA, but in this case here, we're not given a right angle, so we're not using SOHCAHTOA. Let's look to use the law of sines. Remember, to use the law of sines, you need one matching set and one half matching set. Here, the half matching set is what you're solving for, so that would be the g's. And we do have angle G, and we're looking for side G. So now we're looking for the one matching set. But unfortunately, we don't have that. Here we have side H, but not angle H. So that's not a matching set. And here we have angle I, but not side I. So that's not a matching set. So unfortunately, we can't use the law of sines. So here we're going to try to use the law of cosines. The law of cosines, you need 3 sides and 1 angle. But that's another problem, because here I don't have 3 sides. I only have 1 side in the side I'm solving for, so I actually don't have 3 sides at all. So what are we going to do? I'm going to backtrack and look to see if I can use the law of sines. Remember, to use the law of sines, you need 1 matching set and 1 half matching set. And I'm trying to solve for the g's, so I'm going to let my half matching set be the g's. Well, that means I need a matching set. That means I either need to have the i's or the h's. And it doesn't look like I have either of those things. But actually, if I backtrack, can I go about getting a matching set? I think I can go about getting a matching set of h's because I have side h. I can find angle h because I'm given 2 other sides of the triangle. Excuse me, 2 other angles of the triangle. Since I have 2 angles of the triangle, I can just add them up and subtract it from 180 because you know the sum of the angles is always 180 degrees in a triangle. So here's my plan of attack. I'm going to use the law of sines to solve for little g. I'm going to write little g over the sine of big G. That's my half matching set. That equals little h over the sine of big H. That's going to be my matching set. Let's go about first finding angle H by adding up G and I and subtracting it from 180. So here when I add them up, I get that 151.1666 number. I'm then going to go 180 minus that to get 28.83. But then I'm going to convert that to degrees, minutes, and seconds by going to my second and then apps and option 4 to DMS. So now I know angle H is 28 degrees and 50 minutes. So now I'm going to plug into this law of sines that I had set up before. I'm going to have little g over the sine of big G, and that equals little h over the sine of big H. Little g is what I'm solving for, so I'll call that x, divided by the sine of angle G. Well, angle G was 92 degrees, 50 minutes. So I have x over the sine of 92.50. That equals little h, which is 16. So that's little h, over the sine of angle h, which I just found, the sine of 28 degrees, 50 minutes. I'm going to cross multiply. I have x times the sine of 28.50. That equals 16 times the sine of 92.50. And then I'm going to divide both sides by the sine of 28.50 to get the x by itself. So what I'm going to have to do on my calculator is this. I'm going to have to do, so this side cancels, x is equal to this big mess. And remember, when you do trig, when you're finding a side, you just simply press buttons. When you're finding an angle, you always press the second button first. Well, what are we doing? We're trying to find side G. So since we're trying to find a side, all we're going to do is push buttons. All we're going to do is just type this into our calculator as we see it. So here it looks like little g to the nearest tenth is going to be 33.1. So little g, 33.1.